In this video, I will show you how to build your own mobile robot. Designing a robot can be pretty intimidating. However, I want to make this design and assembly process as simple as possible. I also want this project to be a test bed for more advanced systems. Here is part 1 of how to build a mobile robot. The field of robotics is rapidly growing as more and more systems become automated. Tasks previously accomplished by humans, such as the operation of machine tools, driving of automobiles, and even the stocking of grocery stores, are quickly becoming the domain of robots. With all of this in mind, let's get to designing our robot. We should first start with the movement systems. We can divide these into 3 main categories. There's tracked robots. These are good for mobility, but probably have complex tensioners and drive systems, so we probably are better off avoiding that. There are walking robots as well. These offer the highest degree of mobility, but probably have incredibly complex algorithms driving them, so this may be a little bit above our current skill level. So that just leaves us with wheeled robots. Okay, so we know we want a wheeled robot, but how exactly are we going to design it? One idea is to go to history as our example. One of the earliest known robots, known as the Tortoise, was built by Gray Walter, a British cybertician, used a 2-wheeled mechanism along with a caster wheel to drive around with. Since my local hardware store has these in droves, I think this will suit my design pretty well. So, we'll now work on the CAD model for the robot. This took several hours, and I won't show the different iterations and design changes. Needless to say, the different components such as the gearbox and the swivel assembly were heavily modified and required several different iterations. As we saw in the CAD model, in addition to the components from the hardware store, there were also 2 large wheels included. These came from an old weed eater, and I figured these would be cheaper to use than purchasing new ones. I also happen to have a box of NEMA 17 motors, so those may come in handy. In a previous project, I completed a 3D printed gearbox with a 16:1 gear reduction, so this might actually work pretty well. Okay, so I might have misspoke. The reduction is actually 5:1 for each gearbox stage. Considering it's a 2-stage gearbox, this gives us a total reduction ratio of 25:1. Now, if we're using the Mimbia 17 stepper motors, these are, according to their datasheet, 0.33 Newton meters. This should give us a total torque output of 8.23 Newton meters. Not bad for just 3D printed gears. Okay, so now we need the brains. I think I'm going to use an Arduino for this. So, with all these components out of the way, let's get to building. So, in this clip here, you can see all the parts, including the gearboxes. These took multiple iterations since the original ones kept breaking. I eventually upgraded these to use aluminum rods. These actually aren't the most up-to-date design, and in an upcoming video, I plan to use newer ones for a robotic arm printing, so check that out. Besides this and the battery holder, most of the parts just are from ones that I had lying around, so it definitely fits the built from your garage motif relatively well, I believe. Okay, so the circuitry is completed. As you can see here, I've got the 2 A4988 stepper drivers. These are pretty easy to distinguish based on their heatsinks. They're connected up to the Arduino. In addition, I also have a MPU 2950 or a 9250. This is going to be used for inertial measurements. I figured since I plan to use this robot for localization, it might be good to have gyroscope data, so I added that. In addition, I also have a buck converter. I figured, the Arduino usually has a 12 volt to 5 volt converter, but since there's multiple chips connected, this would probably be good to include just in case. Okay, so we've got everything connected. Now let's see how it drives around. Oh yeah, it's a pretty loud noise. Might have to fix that real quick. Okay, so we've got the robot here. Now let's try driving it around some. Yeah, it's definitely kind of loud. We need to probably work on the steppers, get those working a little bit better. So I mean, yeah, it's not winning any races, but for the purposes of testing different types of algorithms, such as localization, this should be okay. Maybe in the next build I'll do a brushless motor-based one. That'll be a little bit faster. Okay, so it looks like it drives around okay. Now let's see how it goes over a ramp. Okay, so not the best results in the world. It may just be due to the wheels. They're a little bit old, so the rubber may be kind of vulcanized, so maybe by fixing that a little bit, it'll kind of make it a little bit grippier and go over the any obstacles a little bit better. Okay, so let's try that again, but this time going straight on. This is usually the part where it kind of stops at. Yeah, it's starting to go. I think if you keep it at low speeds, it has a tendency to ride over any obstacles. See if it gets stuck here. No, looks like it works. On the screen here, it actually shows the IMU data. So I came up with a kind of custom program for this. Apparently with these types of sensors, there can be measurement error. So I took the average of these measurements over a period of time, and then after the calibration cycle is completed, it then subtracts this from the total measurement. Okay, so hopefully this is calibrated now. Let's try driving it around and see how it responds to rotation. So let's go ahead and do that real quick here. Okay, so pretty much expected. It's not changing with forward movements. Let's try rotating it some. So yeah, the update rate is pretty slow. I can fix this probably by changing the code a little bit, but for now it'll probably work. So yeah, it looks like it gives a pretty good reading of the rotation of the robot. I think in future revisions I'm going to try upgrading this a little bit, so we'll just have to see how that goes. But for now it looks like it works pretty well. If you found this video interesting, please like and subscribe. And also catch part 2 where I add computer vision and a SCAR arm to our original robot in order to realize the goal of a fully autonomous mobile robot platform. Well, thank you for watching. Have a great one.